Okay, so before that stopped, and that was even 10 minutes, we were right here. So in the y direction, so we're on number 20, in the y direction, fny is going to equal fg, so fn cos theta equals mg, so fn will equal mg over cos theta. Then you go to sum of the forces in the x direction, which will be equal to mv squared over r. And the only one in the x direction will be fnx. So that's going to be equal to mv squared over r. So that's fn sine theta is equal to mv squared over r. So now where fn is, fill in the mg cos theta. So it becomes mg sine theta over cos theta is equal to mv squared over r. The m's cancel. You're solving for v, so it'll be v squared is equal to r times g times tan theta. So v squared is equal to r was 65 meters, g is 9.81 meters per second squared, and that is the tan of 15. Remember, that's v squared, so you need to take the square root. So 65 times 9.81 times the tan of 15, and take the square root, and you should get, I think, 13.071 meters per second, but I might have hit a wrong button there. I'd check it, but we'll run out of time if I do. All right, number 22 is the identical question, except the r and the theta are different. So again, sum of the forces in the y will equal may, so you'll end up with fny is equal to fg, so fn cos theta equals mg, fn equals mg over cos theta. Go to the x direction, sum of the forces in the x direction equals mv squared over r, so that's fnx is equal to mv squared over r, so fn sine theta is equal to mv squared over r. Fill this in, and you get mg over cos theta times sine theta is equal to mv squared over r. Again, the m's cancel, so you have g tan theta is equal to v squared over r, and you're solving for v. So v squared equals g times r. Whoops, that's really a tan times tan theta. So v squared is equal to 175 meters, 9.81 meters per second squared, and this time it's the tan of 12. So 175 times 9.81 times the tan of 12. And remember to take the square root, and you get a speed of 19.1025 meters per second. Okay? Number 23, again the identical question, only this time they want the angle. So sum of the forces in the y will be 0. So fny will equal fg, so fn cos theta will equal mg, so fn will equal mg over cos theta. Go to the x direction, sum of the forces in the x direction equals mv squared over r. So fnx equal to mv squared over r, fn sine theta equals mv squared over r. Sub in for your fn, so it'll be mg over cos theta times sine theta equals mv squared over r. r's cancel, again you end up with g tan theta is equal to v squared over r. This time you want tan theta, so tan theta is equal to v squared over gr. 85 kilometers per hour is 20, let me try that again. 85 divided by 3.6 is 23.61 repeating meters per second. And you're going to square that and divide it by 9.81 meters per second squared and by 155 meters. So squared divided by 9.81 divided by 155, and now do inverse tan, and you get an angle of 20, so theta ends up being 20.135 degrees. Okay, so the textbook ones are done. Now it's time to switch to the ones on the half sheet. The good and or bad news is the first one on the half sheet is identical to the ones that you were doing. So again, no friction. And so you have Fg acting down, Fn acting this way, this will be Fny, this will be Fnx. Tells you the radius is 50 meters. Wants to know what is the angle if you want to go around at 100 kilometers per hour without friction. So again, sum of the forces in the y is going to be 0, so it'll be Fny equals Fg, so Fn cos theta equals mg, Fn equals mg over cos theta. Then we go to sum of the forces in the x equal to mv squared over r. So Fnx equals mv squared over r. So Fn sine theta equals mv squared over r. So mg over cos theta times sine theta equals mv squared over r. We get tan theta as the m cancels, divide by the g. Tan theta equals v squared over gr. This should be getting easy by now. 100 is really 27.7 repeating. Whoops. Repeating meters per second. You're going to square that. Going to divide it by 9.81 meters per second squared and 50 meters. So squared divide by, and then do inverse tan, and you should get an angle of 57.556 degrees. Alright, so finally number 2 has friction. Okay, so the first part of number 2, though, I think I haven't actually read it, so I probably should do that. So we have Fg going down, Fn going up, Fny, Fnx. And so it says radius, and it's perfectly banked for 60 kilometers per hour. So that first piece is what you use to find the angle. So whenever it says perfectly banked, it's saying find the angle assuming no friction. So do all this same stuff that we just did like 3 times. You're going to end up right here. So I'm taking a shortcut because this video is going to run out before I get to the end. So tan theta is equal to v squared over gr, and that's 60 kilometers per hour, which is 16.6 repeating meters per second, and you're going to square that over 9.81 meters per second squared, and the radius was 70 meters, and you're going to get your angle. So squared divided by 9.81 and divided by 70, and then do inverse tan, and you should get an angle of 22.02388 degrees. Now you're going to add friction in. So friction's going to go down this way, component in towards the center, and a component down, and we're about to run out of tape here.